So for this problem, I'm going to give you one that's a little bit trickier than the ones we covered in videos. And don't worry too much if you can't get it on your first try. Watch the video and go through it. But for this problem, a baseball player wants to try to hit a baseball 400 meters. And he knows that when he hits the baseball, it's going twice as fast forward as it is upwards. How fast does it have to be going upwards in order to travel this 400 meters? And you can assume that acceleration is negative 10 meters per second squared. And you can ignore everything like friction or air resistance. So take a second, pause the video, and then we can go through it together. And once again, don't worry too much if you get stuck. Okay, so let's get started on this one. Like before, we can calculate time. Now this time, time is going to be calculated in terms of a variable, because v sub y is just called v, some arbitrary variable for velocity. V sub x is 2v. Time is unknown. X is known at 400 meters. Y is known at 0 meters. And acceleration is known negative 10 meter per second squared. So now we can start plugging stuff in. We know that v sub y, so the velocity of y, equals time times acceleration. So time equals velocity over acceleration. Now like before, that's the change in velocity. So that's the change in velocity from at ground level to at its peak. But we need twice that, because we both need to go up and come down. So time is twice velocity times acceleration. We still have an unknown in terms of v for velocity. But the good news is now everything is in terms of that. All of our unknown variables are in terms of that v. So now we can go to using a different equation. We say that x position is going to be velocity in the x direction times time, which is 2v times 2v over acceleration equals 4v squared over a. And we also know that x happens to equal 400 meters. So let's try to solve that out. 4v squared over negative 10 meters per second squared equals a change of 400 meters. And that should be positive, not negative down below, because we had our signs backwards earlier in the problem. So now we have this. So now we multiply by 10 meters per second squared on the bottom. And now we're given that 4 velocity squared equals 4,000 meters squared per second squared. So all we have to do is divide by 4. Velocity squared equals 1,000. Now we know velocity equals the square root of 1,000, which is 10 square root of 10. And this is approximately 31.6 meters per second. So this one was a little bit trickier. We had to use some variable for velocity, because we had multiple things depending on the same variable. But the thing was, we were able to use the same simple equations. And we went through, we figured out which variables we knew, which one we didn't. And one of the tricks, when you have a bunch of variables and multiple unknowns, because here when you look at it, we don't know velocity y or velocity x. What matters is to get it all in terms of the same variable. In this case, this variable happened to be v. We made one up because that was easier. So in other cases, you'll use one of your pre-existing variables and solve for every other variable in terms of that. But all that matters is you get it down one variable at a time until you only have one variable left, and then you can plug and chug until you get an answer. And in our case, our answer was 31.6 meters per second, which is reasonable and in the right direction, so everything's good.